Good. So really happy to see you, everybody. Really great. Just present myself. Some people I already know, which is great. New people, my name is Shachar, which is kind of difficult, but you can also call me Leon or Brenner. They both are also my names. With any combination will be okay. By the way, Shachar means in Hebrew the sunrise. So it's sort of like a hippie name, right? It's very nice, but it's really hard to pronounce, so it's okay. We can do Leon. Like Masha said, I'm a PhD student in the Tel Aviv University and the FU. My expertise is indeed Lacan, and specifically autism, which is sort of a crazy field in psychoanalysis today, I think. If you come to the fourth meeting about the unconscious, we're going to talk about psychoanalysis then, and we can open these issues up. Today we're going to talk about paradoxes. My love for this sort of esoteric field comes from my interest in philosophy of mind. And today we're going to sort of try and understand what's the limit of our thinking through paradoxes. Anybody knows Quine beforehand? Yeah? Okay, here we go. I'm happy that nobody else does, because we're going to go really deeply into one of his very popular articles, and you'll get a chance to, after this lecture, say, yeah, I know Quine, and I know what he thinks about paradoxes. So let's begin. I'm going to ask a question. I'm going to ask you questions as we go. First question, very easy. What's a paradox? What is it? And the answer is not in the presentation. What is a paradox to you? Anything could be okay. Mm-hmm. Right, okay. So a clash. You're talking about the clash. I really like that metaphor. A clash between two thought constructs. Okay, great. Any more ideas? I see something bubbling up there, right?
Self-contradicting statement.
Right, contradicting statements. That's also a part of a paradox. This clash, that's what we used to think about paradoxes, this clash in our mind. But actually a paradox is not only a contradiction. It is a contradiction. It is a contradicting argument. But let's say this argument, let's say pigs can fly. Right? It's sort of strange. We feel it's not really right. Reasoning brings us to do some experiments and maybe see if that's true. And I think science has not yet proven this is correct. This is sort of a contradiction, but it's not a paradox. A paradox has a second level, a second step, which is the fact that it seems to be true. So it is a contradiction on one side, but on the other hand, it really seems to work out. It seems to be a real, true argument. Okay. Now, when we deal with a paradox, it's a problem, because our reason tells us this is true, this is okay, this works, but then our reason also tells us this is complete bullshit and we don't know what to do. And at this moment we have two options as philosophers, and today you're sort of philosophers. Okay? So we have two options. The non-philosophical one would be to go home and just watch TV, but the philosophical ones would be either to abandon what we believe about truth or any other thing that relates to the paradox, or we need to find what in the paradox is actually false and sort of say, phew, okay, that was false, so I don't need to change everything I believe in. And I'm going to give you a first example of a paradox, and we're going to have many examples today. That's the whole idea, to have fun with paradoxes. Very famous one, the bottom statement is true. The other statement says the top statement is false. Why is this paradoxical?
Because it excludes one another.
Right, so what? Come again?
It excludes the other, one statement excludes the other.
Absolutely, right. And it sort of continues on forever, right? So if the bottom statement is true, then let's try and investigate it. Okay, so this statement is true. Okay, and this says that the upper statement is false. Okay, so I go back, and this is false, so this means that this is exactly the opposite, and this is false. Okay, so if the bottom statement is false, then this is true, etc., etc., etc. In philosophy, we call it ad infinitum. This is until infinity. There are several ads, ad hoc, It's like after the fact. But we also have ad hominem. Have you heard of that one yet? It's a great one to use, by the way, when you have an argument with your girlfriend or boyfriend. Ad hominem means an argument that is completely not revolving the content of what you're saying, but it's sort of saying that you as a person suck. For instance, I will claim that, I don't know, the political conditions in the United States have created the proper environment for, I don't know, neoliberal candidates like Donald Trump to arise, right? And then you say, yes, but you are ugly, right? So this is an ad hominem argument because it completely disregards what I was saying. It was just saying something about me. So if you have this fight, and it usually gets to that point, right, when you say, yes, but you suck, then you say, but this is an ad hominem argument, and you can continue smiling and winning the argument. So this is a we're going to do some excursions as we go, okay? So this is a paradox about truth value, and it sort of makes us think again about what is truth and how does a sentence actually point at truth. Yeah, so this is just a preview, okay? Let's see another example in a second. Jiu-jitsu, which I'm very much not trained in, but I really appreciate it because jiu-jitsu is sort of a martial arts where you don't just fight, you sort of use the power of your opponent against the opponent. So for instance, if your opponent is sort of like coming to strike you, I think karate you would sort of block it, right? And I think jiu-jitsu you just take the momentum of his hand and sort of like spin him around and throw him in the air and sort of use his energy against himself. And paradoxes are sort of like a jiu-jitsu of reason. What they do is they take reason and they use it against reason, which is really great and fun. Yeah, I put here the example of Karate Kid, which I really like, from '84, and the Abomination from 2010, which I disagree with. But generally speaking, paradoxes are sort of like Karate Kid, but in the field of reason. Let's try and do an experiment together and sort of understand what happens to reason in a paradox. I need a volunteer or a volunteerette. You don't need to stand up. You just sit there, and what we're going to do is you're going to answer 2 questions. They're not going to be very difficult. Okay, so just a very brave volunteer from the crowd, if possible. Yeah, excellent. Okay, so you're ready, right? Okay. Just need to promise to answer truthfully, okay? Sincerely. I'm not going to ask something private, don't worry. But just, no bullshit, right? Second thing, use your full intellectual capacity. You can think about it. You can really think about it. I wanted to use reason. This is the whole practice. And you're going to answer 2 questions, either with a yes or a no. You can choose. Okay? Ready? Good. Okay. First question. Will the answer to this question be the same as the answer to the next one? Yes or no?
I could say maybe, but I guess I would choose.
Right, but so you have to choose. Yeah, no maybes here.
I would say no.
You would say no. Okay.
I'm sure if that's an educated guess.
Well, we'll see. So you say no, and I'm asking you, will you give me 100 euros? No, but you just promised to say yes, right? So you owe me 100 euros, but I'll give you like a chance to change your mind. So I'll ask you again, will the answer to this question be the same as the answer to the other one? You said no, you can change your mind to yes. Probably a good idea, right? So because you don't want to pay me so much money, right? So you say yes, and I'll ask you again, will you give me 100 euro? And you say yes, because you're a sincere and honest person. So we'll settle that after the lecture. But what we see here is sort of like an example of something going terribly wrong with reason. Reason was sort of supposed to help us deal with this predicament, but because we abide to reason, because we are sincere and honest intellectuals and we listen to what reason tells us, we get in trouble. And we owe the lecture 100 euros, which is a lot of money, right? So that's what we do. That's sort of what happens with paradoxes. And let's have another example, and we're going to have many ones in the future. This is one I really like, because when I was young, I used to annoy all the kids in the kindergarten with this, because, you know, it's sort of like, yeah, what about God? And this is the question, could God create a stone so heavy that even he could not lift it? Or its even better version in The Simpsons, could Jesus microwave a burrito so hot he himself couldn't eat it? That's a question Homer asks Ned Flanders, which is a valid theological question, I think. And what's the deal here? This is not specifically about God. Whoever was here last time, we tried to prove the existence of God several times. I bring up God again. But this is not so much about God, but about the quality of omnipotence. When we say that some being, any being is omnipotent, we get in trouble, because if God, let's say, is omnipotent, he can obviously create anything that he desires. Even this stone, which is so heavy that he can't lift it. But then if he creates it, he can't lift it, so he's not omnipotent. So I change my mind. Maybe I say he can't create this stone because he is omnipotent, so he cannot contradict that. But then he is not omnipotent because he cannot create the stone. So it's sort of, we're stuck here between a rock and a hard place, between a burrito and a, I don't know, and something else. So this is another example of a paradox. It sort of starts our brain working on what is omnipotence, what is God. It sort of makes us think. You see, so paradoxes are sort of like, they're not just about truth or false, they're about ideas that might be even very popular in humanity, the idea of an omnipotent God. So we need to think about this if we're gonna abide to this idea of an omnipotent God or a burrito. But seriously, just seriously, I want to say that paradoxes are not just amusing games, which sometimes they are, but in philosophy they are very important because they problematize what we view as knowledge. They force us to understand what's wrong in the paradox itself, or what's wrong in what we believe in the world, like what's wrong with the idea of an omnipotent God. And they sort of force us to doubt what we know. And when I talk about knowledge in philosophy, I'm not talking about knowledge that we're used to. It's not a concept of knowledge that we're used to. And because for instance, this is a good example. You all know that lottery has always been a way to tax the untaxable, right? It's sort of the way to get to the pockets of those that don't really have enough money to pay taxes. And it's really not a good idea to go and fill a lottery ticket because you probably wouldn't win. I've read somewhere recently online that it's more probable to be hit by lightning more than 2 times than to win the lottery. And I'm not sure how many people here have been struck by lightning. Me, myself, not yet. But it's not a very good chance. So I would say don't do the lottery. It's not a good idea. But I don't know that it's not a good idea. I don't know that you're not going to win. Like when you go and buy a ticket, I could tell you I don't recommend to do that. But as a philosopher, I cannot tell you that I know you are not going to win. Because knowledge in philosophy is without exceptions. It is certain. It is something that is 100%, we're 100% certain of that. And that's a conception of knowledge, right? Now, what paradoxes demonstrate is exactly these exceptions in knowledge. They demonstrate that in this thing that we are sure and convinced is true, there are some holes. There are things which do not really function. And when we investigate them, we can learn about our knowledge. We can learn if our knowledge is valid, right? And we can also learn about the way we actually define things as knowledge, like the conditions for knowledge. So it gets even deeper. Now, many philosophers in the past have investigated paradoxes. This has been going on since long time ago. And even Plato talks about some philosophers investigating paradoxes, and we're going to talk about that today as well. And what I want to emphasize is that the findings in philosophy of these paradoxes are also valuable outside the scope of philosophy in many fields, like mathematics, obviously, physics as well, psychology, my field, psychoanalysis, and linguistics as well. There's a lot of concepts that grew from the work of philosophers on paradoxes. And what we're going to do today, the goal today is to learn about 3 types of paradoxes. So we're going to have a lot of examples, but generally we're going to learn about 3 types. You're going to be able to differentiate paradoxes according to types after this lecture, and we're going to directly base ourselves on a paper by Quine called The Ways of Paradox from 1961. Okay, just a nice picture which I always like. Anybody identifies the philosophers here?
A few.
What? A few. So let's start with one of my favorites. That's Foucault, very good, right? This is here. Nietzsche, like a national pride. Yeah, this one also. That's it. Karl Marx. Yeah. The Sartre, yeah, the cross-eyed philosopher, Sartre. You know, and another German? Kant. Very good. And now this is sort of like, we don't know, it could be Plato or Aristotle, I don't know, anyone. These are kind of hard. This guy we're going to talk about today, this is Bertrand Russell, British philosopher, and the lovely Wittgenstein, right there with the beautiful hair. So that's an exercise I like doing from time to time. Before we continue, any questions up until now? Won't be mad if not. Okay, so let's continue. We start with a riddle. It's a riddle about Frederic. He's a pirate's apprentice in the opera The Pirates of Penzance. He reaches the age of 21 when he only had 5 birthdays. That's kind of strange. Like, how can you be 21 and only have 5 birthdays? So this seems like a contradiction, right? But is this a paradox?
28th of February.
Right. So there's an answer, right? So it's not completely contradiction because the chance of a person being older than X years on his X birthday is 1,460. That's because every couple of years, on the 29th of February, there's a day that only comes every couple of years. So Frederic was born on this day, and although he's older, he only celebrated several birthdays until this day. Now, in this sort of, we sort of deal as though this is a paradox. We sort of responsibly dealt with this contradiction, right? We didn't just say, oh yeah, it's just strange, I don't want to deal with it. We sort of like worked on it, and then we learned something. We learned something about the Gregorian calendar. There's a day that comes only once in 1,460 years. So let's try and view a different paradox and see that it's kind of similar. Okay, it's called the Barber Paradox. That's Bertrand Russell's famous paradox, and it goes something like this. Let's imagine there's a town, there's a village, and in this village there's a barber, a guy that also shaves people, which is always nice. And the basic thing we need to accept is that in this village, this barber shaves all of those, and those only, who do not shave themselves. So for instance, if I shave myself at my house, and I do not get shaved at the barber's. If I do not shave myself, then I necessarily am shaved at the barber's. Okay, makes sense? Question that Russell asks is, does the barber shave himself? Now think about it for a second. Okay. In this village, the barber shaves all of those and only those that do not shave themselves. Let's try and think about this together. Let's assume that the barber does shave himself. There are 2 options here, right? He either shaves himself or not. So if he does shave himself, this is a contradiction. because the barber only shaves those people that do not shave themselves. And if he shaves himself, then it's a contradiction from this first assumption. Are you with me? Okay. Let's assume then that the barber does not shave himself. Okay, this is a contradiction as well, because for every person in the village which doesn't shave himself, we know for a fact that he is shaved by the barber, and thus the barber must shave himself. Okay, we have two contradictions. These are our only options, though. What do we do? Right? Everybody with me on this paradox? Yeah, we can go over it again, but this is generally the idea. Now, with Frederic, things were looking bad at the beginning. We're sort of like, what's going on? How can you be this old and only celebrate this amount of birthdays? But then through reasoning, we managed to learn something about the Gregorian calendar. But with the barber, it's a little different, because things were sort of looking simple, right? We said this is a village and a barber. It wasn't looking like a big deal. But then when we started reasoning, we got to a point of contradiction. So, if Frederic predicaments teaches us that a person can be for X years of age at his X birthday, what can we learn from the Barber Paradox? What do you think? Any ideas? The non-quine experts, I'll ask first. Any ideas? What can we learn? Let's go. What do you think?
I think the assumption was false.
What do you mean by false? That's a good start. What do you mean by false, though?
Yeah, it's not true that everyone who doesn't shave himself is shaved by the barber.
Oh, okay. Let's dwell on this issue. Okay, thank you for that comment. So you're saying that it's not true that in this village the barber shaves everyone that doesn't shave himself. But this is an assumption. We can hypothesize that, right? There's nothing wrong with that, logically speaking, right? With this specific hypothesis, logically, independently, it's not contradictory. There isn't a problem with that. It's a problem when we talk about this specific barber in this specific village, right? So I would say we don't learn exactly about the content of the argument itself, about the validity of the argument itself, but we learn something about the world. It's really rooted in what you said. Yeah, we learn something about the world, which is the world of barbers. Yeah, what do we learn about the world of barbers then? What do you think?
That one have to exclude the barber from the statement.
I'll go even further. We have to exclude this possibility from our actual reality, right? So let's try and grasp what this means. So we buy the story about the village. It's okay, we buy it. There's nothing wrong about it inherently. We accept the assumption that it has a barber which shaves all of those and those only who do not shave themselves, and we necessarily come to a contradiction. But then we infer something about reality. We infer that there's no way, doesn't matter where you go in the world, doesn't even go to India, really far, you will not find a village with such a barber. Not gonna happen. Okay, so you can relax, okay, if you're afraid you're gonna do that. The paradox is sort of a proof for the impossibility of these circumstances in reality. So it's kind of interesting because a logical predicament teaches us about something in the world. Yes?
Just like requesting division by zero in mathematics, is that another example of this?
We're gonna get exactly to that, but no, I would not think so. Because a division by zero is a contradiction of the main axioms of the mathematical system. Right? But a barber that shaves all the people that do not shave themselves is not a contradiction of, I don't know, barbers, right? So it's sort of different, right? We will see the difference in a second, okay? Everyone with me on this one? So not gonna search for these kind of barbers, okay? It's not gonna happen. So we learned something about the world, and this is the first type of paradox there is. This is called veridical or truth-telling paradox. This is coined, by the way, with this lovely hat. This type of paradox produces conclusions which are absurd, but then they demonstrate a truth. They provide us with knowledge about the world through this absurd conclusion. So great, now we know that there are no such barbers. Now, the Barber paradox sort of teaches us a truth which is not very interesting, I would say, right? It's not really interesting to me that there is no barber like that in the world. If I'm not a mathematician, which will take it to a different domain, but generally I do not search for these kind of barbers, so it's not very interesting. But, you know, there are some other truth-telling or veridical paradoxes which do teach us something interesting about reality. And we're gonna see a couple of them in a second. So this is the first type. And now we're going to get to the second type of paradoxes, which is called Falsidical Paradox. This is a term invented by Quine. The second type of paradoxes produces a conclusion which is absurd, and actually it's false. It's not true. It doesn't teach us anything because these paradoxes rely on a false argument or a faulty set of deductions. Okay, so it's not, the Barber paradox was argumentatively well built, right? But these kind of paradoxes will look different, and I want to give you a first example by Augustus de Morgan, and it goes like this. It's a mathematical paradox, okay? Keep your eyes open. I'm going to explain it. Don't worry, I'm not such a... I am a math enthusiast when it's in the field of philosophy, but arithmetics is not really my field, but I promise it's going to be simple and we're going to do this together. So first assumption in our deduction here is that x equals 1. Okay, so x equals 1, that's completely valid and we can do that. Now, if x equals 1, I can base another formula that says that x squared equals x. That's quite obvious because x equals 1 and 1 squared equals 1. That's exactly what we see here. Okay? I'm gonna try and pay attention to this hollow gaze when you lose me. Okay? This is going well so far. Now, mathematically speaking, I can subtract 1 from both sides. I can do that, right? I can just do minus 1 on both sides. So x squared minus 1 equals x minus 1, that's completely mathematically valid. Now to the only a bit complicated stage, but you probably remember this from school. There's something that's called factoring trinomials, and this means that this sort of monster here equals to this one. I'm going to do this real quickly, okay? You remember how you do this. You time x times x, that's x squared. Then I do x times 1, that's x. Minus 1 times x, that's minus x. So x and minus x sort of cancel each other out. And then I have minus 1 times 1, that's minus 1. So this part equals this guy. These are completely equal. I just sort of written it differently. Now what I do right now, very easy. You also remember this from school. I'm going to divide by the two factors that are existent on both sides of the formula. So I divide by x minus 1, and this turns into a 1, and this turns into a 1. Right? So this means that x plus 1 equals 1, because I've divided by the same factor on both sides. Now all I have to do is to place my first assumption here, if x equals 1 right here, and I have 1 plus 1 equals 1, 2 equals 1, right? So math is sort of like not really true, according to this paradox, because it makes us believe that 2 apples are actually equal to 1 apple, which is strange, right? So this is a paradox by Augustus de Morgan, but it is a Falsidical paradox. So anybody sort of found out what's the problem here? What's the faulty argument? So let's just leave this math thing behind. You know, it's just false. We can just leave it behind. But no, there's something here which is inherently wrong.
So second one?
Let's try and guess together. Yes.
Second line, because that just goes 2 for 1.
Second line, why is this not correct? According
Because in abstraction, it's just true in the case of one, but
according to 1, and this is based on 1, this formula is true. If 1 wasn't true, this formula might not be true. But we're assuming that x equals 1, and I can assure you that 1 square equals 1. So this one works. Okay. Yeah?
The second with the x, because if you move the 1 by
Which one? Sorry, which?
a number 5.
A number 5, right?
If you move the 1,
Yeah?
you get x equals 0.
Right, so x equals 0, and then I station my x right there, so 1 equals 0. It's sort of like as horrible as 1 equals 2.
Yes, but that means that there's something fishy with the x.
Right,
It's not sure what.
definitely right. Guys, I tell you the truth, this does not really trouble mathematics. There are much worse things that trouble mathematics. If you know, like a very, very nice German mathematician, which I like is called Gödel, and he's done much better work to show that mathematics is completely invalid. But this does not do that. So let's try. Let's try a bit more. Do you know? You have an idea?
Wait, this one?
Yeah.
X minus 1 is 0, so you can't divide.
Perfect. Okay, so we have a mathematician here with us. It's very simple. One of the axioms of arithmetics is that you cannot divide a number by 0. Right? That's an axiom. We'll talk about it in a second. And x minus 1 is 1 minus 1. That's 0. Right? And what I did right here is I divided by 0, so I got this absurd answer. But it makes sense because math is based on these rules, and when I break the rules, I won't get math. I'll get like, I don't know, abstract art. I don't know what it is, right? So what we have here is x minus 1 equals 1 minus 1 because of 1 equals 0, and you can't divide by 0. Why can't you divide by 0, by the way? Do you guys know, or just listening to your teacher? Not good, guys. You shouldn't listen to your teachers like that. You should always criticize what you're said. But let's think about it logically. Like I have an apple and I need to divide it to 0 parts. It sort of commonsensically doesn't make sense. Okay, I see you're not into it, so we're gonna go to another subject. We might talk about it in the future. But this is a perfect example for a Falsidical paradox. Why? We had a set of reasonings and we got to a conclusion which is contradicting, but on the way, one of the arguments is false. It's a big difference from the Barber argument because none of the Barber arguments were false. This one has a false argument, and that's why it's falsidical. Now, there's another very famous paradox, which is a falsidical paradox. I'm gonna demonstrate it now. And what I want you to try to think about, is what's false about it? What is the false argument in this paradox? And this is the paradox of Achilles and the tortoise. This is a very nice story, which I like. You know, Achilles is like the hero, which his mother went and, you know, she dipped him in the river, and he sort of became invisible except for where she was holding him, right, in his heel, Achilles' heel. Right? If you've seen last Louis C.K.'s bit, he does a good bit about Achilles and the heel. Now, Achilles was a really great, really great in sports. He was really strong. He was really wonderful, beautiful body, etc. And one day he's sort of bored and he decides to have a running competition with a turtle, which is strange, I know, but that's what they did at that time. And Achilles is sort of a really nice guy. He's not you know, he's not so macho and everything. And he tells the turtle, you know what? You have a head start. You know what? I don't care. You have a head start, and I'll start after you begin. So they start this competition, and the turtle sort of goes for some time. Let's just, for the sake of the argument, let's say he goes a half a kilometer. Okay, he's walked for a half a kilometer, and Achilles sort of like sees him there, and he starts running because he wants to get the turtle. He wants to get to the point where the turtle is. So we say that Achilles runs for half a kilometer, right? But obviously when Achilles runs, the turtle doesn't wait for him. It doesn't wait for him to catch up. He continues walking. So let's say Achilles runs half a kilometer, and as he runs half a kilometer, the turtle is slower and he walks a quarter of a kilometer. Okay? So when Achilles reaches this point where the turtle was when he started, he has a quarter of a kilometer to catch up to get the turtle. So he heads on his way. He doesn't stop, he just continues, but we break it up like this. So he has a quarter of a kilometer to go, and let's say that as he does the quarter of a kilometer, the turtle, of course, doesn't wait for him. He does an eighth of a kilometer as he does the quarter of the kilometer, right? So Achilles is right here, and the turtle is right here, and now he has to catch up an eighth of a kilometer, and he does it, and as he does it, the turtle moves for half of that amount, etc., 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 ad infinitum. So, okay, so it's 500 meters, I don't know, 300 meters, gets to a meter, is really close. He needs to catch up in a meter, and then he does it, and as he moves, the turtle moves like 10 centimeters more, right? And then he needs to catch up 10 centimeters. As he moves, the turtle moves 1 centimeter, and more and more and more until they're really, really close. But Achilles never gets to the turtle, right? That's a problem. And this is a paradox by Zeno, and what it eventually signified is that movement is impossible. That's what Zeno thought. Movement is impossible. What we think that we move, it's actually not true. Okay. So, are you with me on this one, or should I go on this again? Can anybody? Never actually reaches the turtle. This is a perfect metaphor for, I would say, desire. Right? We always almost get there, but it's really always getting further away. So, sorry? We think we're in progress, but actually we're not going to get that turtle, right? We're never going to get the turtle. Yeah, let's go.
Because the turtle always moves relatively forward to the amount that he gets closer to it.
Right, it's always like that. It's always like that. It's a question of distances. And what we have is a series of an infinitely shortening distances. I mean, like it starts with half a kilometer, then a quarter kilometer, an eighth of a kilometer, times 16, 32, 64, 128, etc., 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 forever. But there's always a tiny difference there, right?
It's not a velocity question.
No, definitely not. Exactly. This is not a velocity and not a question about speed. It's a question about distances. Yeah.
I don't know if this adds anything to the conversation, but if you had a grid structure, you could place a line at 1, and they're going, both of them move towards 1, but one of them is closer to the one at the beginning, it's at half. They both approach 1, but they never reach it. I don't know if that adds anything.
Right, so you add like this 1, which is interesting by itself. You add this figure of the 1 as the... Absolutely. It's approaching 1, but it never gets to 1. That's what Zeno said. Absolutely. Like even, I gave here an example, I think. Yeah, here are the two series. So this is what we're sort of saying that this runs out for infinity, but this would describe the predicament here. It's sort of like we're trying to catch up, right? So half minus quarter minus eighth, and we want to get to 0, but we're not getting there. We never get there. So I'll tell you something, like if you take a turtle, backyard, and do a competition with it, you're gonna win. So what's the problem here, right? Like, I just want to calm you down if you think your turtles are sort of like that. But they're not, there's a problem here. Any ideas?
You can't divide it like that. I don't know why, but you just can't.
Okay.
It's a kind of a trick.
Yeah, well, for Zeno it was completely true, right? He didn't try to trick people. But today you're right, you can't. This is not true. This is definitely not true, this assumption. Mathematically invalid. And I'll tell you what it is, okay? Unless someone wants to feel great and tell the answer, you know? The thing is this conception which we call convergent and divergent series. Now, at the time of Zeno, we had this mathematical idea which we also sort of shared here because it seems logical that any infinite progression of shortening distances will maybe equal infinity or never equal 1 or never equal a finite number. But today in math we know that's not true. There's actually several convergent series which are sort of endless, and you see this one just goes on forever, and they actually equal a number. They converge into this number, and we today say that they actually equal a finite number. On the other hand, this divergent series are series which never equal a number. For instance, this one, 1 plus 1 minus 1 plus 1 minus 1, will never converge on a number. So if an infinite amount of shortening distances can be equal to a finite number, then Achilles gets the turtle, right? So what we learned here through Zeno in this paradox is something very useful in mathematics. This is something which is used in mathematics to develop mathematics, and is sort of like rooted in this idea of this guy and a turtle. What we saw in this paradox is there is a very basic false assumption, and now we know it. The assumption that there is no such thing as a convergent series. The convergent series was not part of the idea of Zeno, Achilles and the turtle, and he thought that the series will never reach a finite number. But today we know it's not true, and we can say it's sort of like dividing by 0. Right? What Zeno did is sort of like divided this thing by 0. He did something which is false. So that's a Falsidical paradox. Now I want to give you a paradox, and I want you guys to tell me what kind it is. Is it a veridical or is it Falsidical paradox? And this is the grandfather paradox, which I really like myself because I really love sci-fi, as the people that were here last week know. And it was sort of invented by this journalist and science fiction writer, René Barjavel. And he was trying to think if time travel was possible, which to me is really intriguing and has been horribly dealt with in Hollywood, I think. Except for several movies, which I really like. 12 Monkeys, have you seen it? 12 Monkeys, I think, is a great time travel movie, right? And the rest, like Back to the Future, is sort of like, you know, sort of strange. And we'll see. Sorry?
What do you think of Looper?
Looper, right. That was, yeah. That's a good question, yeah. I'm not sure. It was a bit too Hollywood for me, but yes, it's on the same concept of 12 Monkeys, I think. They try to do the same thing. So in his book, Les Voyageurs Imprudents, what René Barjavel asks is, if somebody goes back in time, yeah, and he kills his grandfather before his grandfather actually has children, one of the traveler's parents is thus never born, and then the traveler itself is never born, and then he can't go back in time to kill his grandfather in the first place, or the last place. It depends on how you look at it, right? So this is an interesting question, like, because, you know, maybe time travel is possible, but what will happen? So before you give me some answers, which kind of paradox it is, if you remember in Back to the Future, you remember what happens? When somebody kills your dad, you're sort of like, oh no, I'm turning invisible. You remember that? It's sort of like very strange. That's their solution. But I'm asking you as like serious philosophers, what kind of paradox is this? What do you think? Is it a Falsidical paradox? Does it have like a argument which is inherently false? Or is it a Veridical paradox which teaches us something about reality? Neither nor. Why do you think?
Because you said you will talk about 3 types of
Oh no, that's clever. I wouldn't say this is the third type. The third type is much more frightening, you'll see. This is one of the two. I would definitely accept both answers if you have a good argument to support them. What does it teach us about reality? Let's think. That, yeah?
I assume that time travel is impossible.
That it's impossible to go back in time. It's sort of like if we agree that the argumentative line is true, it's okay, then we get to the conclusion it's sort of like the barber, right? This thing is not possible, right? That's one option, right? By the way, what does it say about going to the future in time? Not much, right? Not much. It only tells us that we can't go back in time, but maybe we can go to the future. I don't know. So that's good. It could also be a falsidical if you find something inherently flawed about the conception of going back in time. And I guess this is dependent on the framework that you choose, right? So there's several answers to this question. Yeah. So we said the Barber is definitely a veridical paradox because it teaches us that nowhere in the world we're going to find a village with a barber that shaves all the people that don't shave themselves, right? So it teaches us something.
So veridical means that it teaches you something not true.
Right, exactly. It's a veridical or truth-telling paradox. And falsidical paradox is sort of, it doesn't teach us anything except that one of the arguments there are sort of faulty. And the paradox itself doesn't teach us anything exterior to his line of arguments. So you think it's veridical? Yeah, that's a valid answer. Yeah, I would say it's veridical because it sort of teaches us something about the reality of time travel to the past. But maybe we can go to the future and kill our children, right? That's sort of like, whew, okay, at least we have that, right? Okay. Another paradox. And again, I want to ask you guys, is this a veridical or a falsidical paradox? We're getting to be experts in paradoxes here. This is the paradox of Theseus' ship, another very ancient paradox. And when we think about Theseus' ship, it's a very famous ship. It did a lot of conquering and conquest. It had this history, it did stuff in the world. Right? It's this ship, it's not just any ship, it's a specific ship that even after Theseus has died, has remained a legend. It's still something with an identity. And what I want to ask you, and we're going to do sort of like this survey. Okay, you can lift your hand. I'm going to ask you several questions in a progression. So this is Theseus' ship. And let's say a couple of years after all the conquests, one of the parts of the ship was sort of broken. You see this sort of like sail here was ripped, and the ship went to the harbor, and somebody replaced it with a new red, red is just emphasized. It's just a new sail. Let's say it's the same color. What I want to ask is, do you think this is still Theseus' ship? So if you think this is still Theseus' ship, you can raise your hand right now, right? And if you think this is a completely different ship, you can raise your hand. Don't have to. Okay, yeah, seems reasonable. I want to progress with this question. So let's say in a couple of 100 years, this is sitting in the museum, let's say, okay, and sort of successively different parts start to break, like this stuck here and this little part there, and they start to break, and in the museum they're replaced. They're progressively replaced up to a point where every part of that ship was replaced by a new part, progressively. Okay? Now I'm asking the same question. Do you think this ship is Theseus' ship? Okay, so I'm asking, is this ship the ship of Theseus? So now, if you believe that, we're going to raise our hands. And okay, so less people, I see. Okay. And people now are a bit skeptical. Who doesn't think this is the ship? Okay, so we have some skeptics here in the crowd. We're going to take it one step further. Okay, let's imagine that in the course of this progression in the museum, where these tiny parts were sort of progressively taken apart and replaced, somebody working in the museum went to a harbor in another place of town and sort of like slowly started to build a ship from all these parts that were broken. So now we have this ship that's made of new parts, which sort of was Theseus' ship, but now we have a ship made of those parts that were broken. And now I ask you, which one is the ship? Which one is Theseus' ship? Ship A, which was the actual ship, like a couple of hundreds of years ago, but progressively changed, or B, the ship which is composed from all these old parts of Theseus' ship. So now you have to speak a bit, not only raise your hand. Who thinks A is Theseus' ship? Everybody agrees A is not the ship? Who thinks B? Yeah? Do you have? Can you base your thoughts?
Because it's originally his ship that he's even rebuilding it. It's still part of the original ship that was owned.
Why is it originally his ship, though?
Because it was his to begin with.
Right, but you know, this was his to begin with as well.
These will be replaced by new parts that weren't like maybe touched by him.
So what, according to your idea, this is completely valid what you're saying. So what is it, what is this essence of identity? What makes this ship be Theseus' ship and this ship not be? What does this ship have that this ship does not have?
He actually stood on that ship.
So he actually stood on what exactly? Because you know, this, let's say nobody knows that this ship exists. And only this ship exists in the museum. And nobody knows about this one. Everybody in the world is convinced that this is the ship because it's in the museum. It's like the Mona Lisa. When we go and see the Mona Lisa, we know this is the Mona Lisa, right? But then everybody thinks it's this one. What makes this ship the real ship? What do you mean he actually stood on it? Because everybody believes he actually stood there.
Yeah, he captained it, and that A is his ship is an illusion. It's more easily digestible because cosmetically it's probably looks better in a museum.
Okay, but why is it an illusion? What is it lacking? That's what I want you guys to sort of synthesize. What is lacking here and in existence here?
Same matter and material made of.
Okay, so this is one answer. This is one basic answer to this paradox. Identity is materiality. Material, original material, actually says, like when I talk about identity, I talk about the actual atoms, let's say, that consisted when this ship was on all its conquests, etc., etc.
But maybe that's exactly the problem, because if you could ask Theseus, which is his ship, maybe he's much more connected to the first broken one, because he has many memories and emotions connected to that one.
Perfect. That's another answer to this paradox. People saying there is this form of identity which is completely independent of material. It doesn't depend on material, it depends on sort of like, I don't know where exactly we're taking this, but this thought, and you're saying it's Theseus is in charge of telling which ship is which, right? So there's something not corporeal about it. Okay, so we have two contradicting ideas. So you think that A is Theseus' ship? Yeah, good, okay. I want to dwell on the B, for instance, because this is the commonsensical answer. You know that most of the cells in a human body change as we grow. And like, I don't know what exactly the cycle is, but again, every couple of years, we sort of like have a complete change of particles. But are we the same people? Because what you said right now, just now in the back, is that you're not the same person you were 7 years ago completely. You're just a different person. And all these atoms or molecules that are sort of digested away, that's you, but they're completely gone. So you're not in existence right now.
How does this relate to cloning something?
To what?
How does this relate to cloning something?
Absolutely. So that takes us one step further, and with 2D, so I'm going to go one step back just a second, to the transportation paradox, which is based on the same idea. And it complicates it. It's just, I don't know how you fancy Star Trek. I really like Star Trek The Next Generation because I think Patrick Stewart has the most beautiful British accent in the world. And he's a great captain. And I think making a Frenchman a captain of a starship is genius. But what they do there in Star Trek, they do this like, you know, this beam me up, Scotty, right? They said beam me up, Scotty, and then all of a sudden they disappear and they appear somewhere else. The Chinese did that just last week with a futon. They sort of teleported a futon to a satellite in space. But the idea of teleportation, let's say, when we have the technology, is sort of like a system. It's like a scanner. It's like a 3D scanner that scans all the atoms in your body. It has a model of all the atoms in your body. And what it does, it destroys the atoms in one place and sort of prints them, 3D prints them in another place. So it just sort of copy you to another place, and then you can get from Earth to Mars in 5 seconds. Problem is what happens if the machine is a little faulty and then it copies all your molecules on one place, pastes it in another place, but then forgets to destroy the molecules in the first place. So now there are two exact copies of yourself. And I ask you, who is actually you? So who should I kill? Who should I chase and like, oh, you need to die now? The one that's on Mars, or the one on Earth. If we abide to the idea of materiality, we're in a problem, right? What's the original material here? Now, philosophers try to give a couple of answers to this idea. First one that we can use is a very ancient philosopher, Heraclitus, which I really like. He talked about this river. If you know, it's a very famous quote. He says, all things go and nothing stays the same. Very poetic. And he says, one could not step twice into the same river. Because when you step into the river, the water constantly changes. It's not the same river. That's what Heraclitus says. So actually Heraclitus says that materiality has nothing to do with identity. Right? There's something else. It's a good question. What is it? A more contemporary theory about this specific paradox tries to differentiate two kinds of identities. Numerical identity, which means that a thing is the same as something else. They are one. In German, you have a word for that, which I was really happy to see. Dieselbe, yeah? And dasselbe, sorry. And there's another identity which is qualitatively identical. That means that they share the same properties. So these two ships share the same properties. That's das Gleiche. Yeah? Now, this theory that tries to solve this paradox sort of gives us an idea of four-dimensionality, of a universe which is four-dimensional. Every object exists in 3 dimensions. Let's say I exist right now, but I also exist in the dimension of time. So you can think about a progression of infinitely small time slices that in each time slice I change. My molecules change, I change a place in the world. Now, what this theory actually says that no object in 3 dimensions is numerically identical. It's not numerically identical because here I change. Right now I've changed. But what it does says that this progression of object, of 3-dimensional object in time, is identical to itself. So they talk about a 4-dimensional dimension of an object. And if I look at this whole progression, I can say that this is the ship. Right? Kind of strange, right? But what my point is that these things make people think and sort of like invent ideas which might have a big effect on a lot of other things. Let's say the world of physics. This idea of 4-dimensionality also has an impact on physical theory, on theories in physics. And yeah, you can definitely read it in this article because it's a little complicated, but we can talk about it later. So, we have finished the first 2 types of paradoxes. We have one last type, which is unfortunately much more perplexing than the ones we've already seen. Okay, so I know it's a bit hot, but I need you to sort of like saddle up, take a big breath, because it's going to be more complicated. Okay. Let's begin with Kurt Grelling's paradox. Again, very old one. In order to understand this paradox, we're going to define 2 adjectives, 2 concepts. Okay, it's very simple. First one is autological. Okay, an adjective is sort of a description of something, right, of a noun. An adjective is autological if it is self-descriptive. Autological is a self-descriptive adjective, means it describes itself also. Here are some examples. Short is an autological adjective because it's short. It's not very long, and you know in Germany words are very long, so this is definitely a short word, right? English is also autological because it's written in English, right? It's also English. And maybe a very good example is polysyllabic, means it has a couple of syllables, this word definitely has a couple of syllables. So this adjective describes itself. That's why we call it autological. Okay? Now on the other side, heterological is an adjective which does not describe itself. It's a non-descriptive adjective, and here are a couple of examples. Long is a very short word. Yeah? It does not describe itself. German does not describe itself because it's written in Hebrew, in English, sorry. And monosyllabic is definitely not monosyllabic because it has more than one syllable. Right? So all of these adjectives do not describe themselves. Are you with me until now? Okay, it's important. Yeah? Now, the paradox arises when we ask the following question. Is the adjective heterological a heterological or autological adjective? Try and think about it, okay? What we're asking is because heterological and autologicals are descriptions of adjectives, we're asking is heterological, which is an adjective, is that adjective heterological or autological? Okay, so we have two options. It's either heterological or autological. So let's try the first one. Let's try if heterological is autological, in fact. Okay, what does it mean? It means that the adjective heterological is true of itself, right? Now, if it's true of itself, it makes it heterological rather than autological. Okay, I'll repeat that again, okay, because it's a bit confusing here. Let's assume that heterological is autological. This is our assumption, that heterological describes itself. If heterological describes itself, what does it mean? What is the quality of heterological? Heterological, because it describes itself. But then we assume that it's autological and we get to a contradiction. So this doesn't work. We cannot assume that heterological is autological. Let's try the other side. Okay, guess what? It's going to be the same. So heterological, we assume that heterological is heterological. That means that the adjective heterological does not describe itself. It isn't true of itself. If it isn't true of itself, then it is autological. But we assume that it is heterological. So we get to a contradiction again. Okay. Now, please bear with me. I know it's a little on the verge. There is a big difference between this paradox and the Barber's paradox. Yeah, not the complexity, but the actual structure of this paradox. Because in the Barber paradox, we got to a contradiction. Well, it was sort of similar. We had two choices, and both of them didn't work, right? But we could declare that there is no such village. We sort of like go out of the world of the paradox and say, okay, there's no such village. But with this paradox, there's actually no premise we can say is not true. We merely defined two forms of adjectives. Adjectives which describe themselves and adjectives which don't describe themselves. And that's completely valid. And we got a really big problem. I can even simplify this and not use this whole autological, heterological thing and just say, ask the question, is the phrase not true of itself, true of itself? Right, I don't even need to go to heterological and autological. I just ask, is this sentence not true of itself? True of itself. Same essence. What we find is that it is true only if it is not, and then we get to a contradiction. Now, this is generally how you look like right now, okay? And it's not a problem because this is what these kind of paradoxes do to people. They have a name, they're called antinomies, and they're the third type of paradox. What this paradox does, it produces self-contradiction by completely valid reasoning. There's nothing wrong about the reasoning, and there is no premise which we can say actually doesn't exist in the outside world. They don't provide specific truth, but they point to an essential crisis in the basic way we think. Right? So they're not so easy to deal with. They're not saying, okay, there is no village. They say the whole way that we perceive truth and false is actually faulty. Right? And that's what we get here with the heterological paradox, it forces us to change the way we think, the very basic way we reason. Now, Grelling's antinomy makes us distrust adjectives, which is sort of a big deal because we constantly use adjectives on a daily basis. When I use the adjective red, I am convinced that I can say that this table is red, and it actually means that there is a table in the world which is red. Right? It's very basic. We use adjectives all the time to describe our reality. But what we also believe is that all adjectives should work this way, right? It's not very complex. When I use an adjective, it should point to something true in the world. But what Grelling shows us is that it's not exactly this way. That we should be critical, that we should be careful when we use adjectives, because we could be saying very wrong things. A good example here is Christina Aguilera saying you're beautiful no matter what. And actually Grelling says not necessarily, because there is an adjective here and it is problematic. Okay. Now, I don't want you to get too worried like you were when we talk about the turtle. We've experienced this many times in the past. And this is another paradox, which is an antinomy by Epimenides the Cretan. And he says all Cretans are liars. And he was apparently a Cretan himself, right? And if he speaks the truth, he is a liar, and therefore not all Cretans are liars. This is the liar's paradox, the very famous liar's paradox. Now, there's some loopholes in this version because maybe some Cretans are liars, but others are not. And maybe Epimenides is not a liar. Or maybe all Cretans are liars that sometimes tell the truth. Maybe that's the fact. But I can simplify this into one sentence. I am lying. Or this sentence is false. So when you articulate this sentence and try to logically reason with it, you get to an inherent contradiction. What do? In this point, we need to rethink the whole way that we talk about truth, the whole way that language works, and several people have done that in the past. So I want to just summarize what we did until now. We differentiated between three types of paradoxes. A veridical paradox has this surprise, oh my God, what's going on? But then this surprise quickly turns into a truth, a proof about something in the world. A Falsidical paradox starts with a surprise as well, but then we see it's a false alarm because there's a very false argument in the progression of arguments. Now, antinomies pack a surprise as well, but they can't really be accommodated, and they force us to completely change the way we conceptualize things. Like I wrote here, to repudiate parts of our conceptual heritage. And then we get to this subject. Yes, we have done this thing many times in the past. And to tell you the truth, I believe that these sort of processes where we completely rethink the way we function happens in many domains in human reality. It could happen in science, in art, in politics, and also in our love life. I think these sort of processes happen all the time. And maybe a good way to think about it is to think about Copernicus. Because Copernicus had this idea about Earth and the Sun. It sort of was groundbreaking. And even his followers, the people that actually said, yes, you are right, Copernicus is true, they called his theory the Copernican paradox. Meaning it was so much unreasonable to think that, let's say, the Earth revolves the Sun, that they called it a paradox, right? And we today call things like the liar's paradox and Grelling's paradox as paradoxes. But then, with time, we know that it's not really a paradox. Another example is abstract art. When it came to the word, sort of paradoxical. That's not art. It was completely illegal. Like the paradox here, the liar's paradox, completely illegal when we think about it. But then eventually we got used to it and we did some fundamental changes in the way we perceive art. So this happens all the time. And when we think about Zeno's paradox, this probably was an antinomy at his time as well. There was no way to solve it. It's sort of a dead end which we could not infer anything from it. Today we're really clever and we know all about convergent series, but in Zeno's time, mathematics was not that developed. What Zeno's paradox did, he drove us to create new conceptions, new basic conceptions of what a series is. So, there are solutions to Grelling's antinomy as well, which demand we change the way we perceive truth and false values. It has to do with sort of like a series of truth arguments, of truth values, and you can read about it in Quine's paper. We can assume that in 2,000 years they will look completely basic. We'll say, all these people will say, oh, why did these people feel so weird about it? Obviously, truth is not either truth or false. It's like there's like a progression of truth and false values, right? Therefore, what I suggest is that we continue thinking and challenging the limits of thought. And this is a very nice quote from Quine. He says, one man's antinomy is another man's falsidical paradox, give or take a couple of thousand years. So what we just need to find out is how to change the basic conception of knowledge in order to make these paradoxes into falsidical ones. Okay? Now, I want to ask you guys, what is the essential difference between antinomy and a falsidical or veridical paradox? Like from what we discussed right now. What did you guys sort of adopted from what we talked until now? What is the basic difference? I just want to do like a summary of what we talked about. Okay, so what do you mean?
The perception, how we think about it, or that's
So what's the difference in perception? That's exactly what I'm aiming at, yes. What was the difference in perception of truth here? I'm challenging you guys, yes.
If you're looking on Talmudic or Marav, Jewish, very complicated things, it's all about that.
It's all about?
Just creating paradox and doubts in your thoughts all the time.
Mm-hmm.
Because it's going to be always God, and then you can sharpen your brain, you can get closer and closer to the truth. We never get to the truth, but this is again maybe the development of thoughts.
The development of?
Of thoughts.
Of thought, right. Right, I would definitely agree. I would say antinomies are sort of like a tool that we can implement in order to make major changes in the way we think, in the way thought works. Whereas veridical paradoxes will help us learn about specific things in the world. They will do changes which we could say are semantic in our perception of reality. Whereas antinomies make paradigmatic changes. They don't change a specific knowledge, they change the paradigm of knowledge completely. Now I want to give a last example before we say goodbye for today, and that's an example of another antinomy which is sort of not really solved until this day. So I want to sort of give it out to you guys. Maybe you think about it at home and find a solution and could progress knowledge, philosophy, and mathematics. This is a paradox that we bestow on Russell again. And Russell has this thing that's called class theory. It's very similar to group theory. And what it deals with classes. So the world has many classes, let's say. Okay, there's the classes, for instance, of all cows. This is sort of a group which sort of includes in it all cows, or all German people, or all philosophy lovers. These are different classes. When we talk about classes, some classes have subclasses. So, for instance, the class of all cows includes a subclass of the class of all brown cows. Right? There are brown cows and these are the white cows, and this subclass is included in the class. Up until now, we're okay? Yeah. Some classes include in themselves. Okay, for instance, I would give you an example. The class, which includes all classes with more than 5 elements. So let's think, which class has more than 5 elements in the world? All men, all women, more than 5 elements, right? All white chairs, right? All video cameras. All of these are classes which have more than 5 elements. The class of all classes with more than 5 elements has all these classes in it as a subclass. And it also has itself. Why? Because it has more than 5 classes, right? Because there are more than 5 classes of things that have more than 5 classes. Okay. There are some other classes which do not have themselves included, like the class of all classes with less than 5 elements. Why? Because the class of all classes that has less than 5 elements obviously has more than 5 elements. There are more classes of things in the world which have less than 5 elements than 5. Then this class does not include itself as a subclass. Okay? A bit complicated. Okay. The question is even worse. And it raises a big question about mathematics in general. What Russell asks is, what about, I'll read it slowly, what about the class of all classes that do not include themselves as a subclass? Does this class include itself as a subclass? Okay, let's think about it again. All the classes there is a class which includes all the different classes which do not include themselves, like the class of less than 5 elements, right? There are more classes like this, and there's a class that includes all of them. The question is, does this class include itself? Okay. Now, this is quite complicated mathematically, and the problem that this antinomy really doesn't have a valid answer up until this day, right? So it's sort of an imperative. We sort of got this imperative from Russell to change the way we think about mathematics. Because in Russell paradox, we don't even talk about truth values. We don't even talk about what is true and what is false. We talk about this membership, this relation of membership. So we can't even use this argument about truth and false values. And this is much more problematic. And what I just want to say in general, that Kurt Gödel, this famous mathematician, which was also schizophrenic, which I really appreciate in artists and mathematicians specifically, he implemented these intuitions in sort of saying that mathematical systems don't have a real axiomatic basis. And that's really problematic, right, up until this day. So we're going to finish with this thing. You can look it up online and maybe think about it a bit more. And talk to me if you have a solution. Okay? Next week, we're going to talk about consciousness. It's going to be quite different than this lecture. We're going to talk about the structure of consciousness, meaning what is it to be conscious? Can we explain what consciousness is? And I'm going to give you some models, some philosophical ideas that try and explain what is consciousness actually in reality. So you're definitely invited. I was really happy with all your comments today. So if you come next time, please comment even more. And thanks. You're welcome to stay and chill and talk after. Thanks.